Hello scholars, welcome back to the Educational Rose. In today's video, we're going to be creating a photoresistor project using the Arduino Uno R3. With that, let's get started.
Before we start coding or do any type of circuitry, I'm gonna give you a basic overview about photoresistors. Photoresistors are just resistors, but they are light dependent, meaning that their resistance changes according to the amount of light that hits them, which means they have this very unique ability that we could use to create some fun and useful projects, one of which is a automatic night lamp, which we're gonna be trying to achieve in today's video. With that, let's start hooking up this photoresistor. For this project, the components you'll need are an Arduino Uno R3, one breadboard, one LED, one 330 ohm resistor, some wires, one photoresistor, and a 10k ohm resistor. Firstly, hook up the GND port of your Arduino to the ground rail of the breadboard, and hook up the 5 volt of your Arduino to the power rail of the breadboard. Now let's see how we could connect our LED to the Arduino Uno. First, connect the anode of our LED to a 330 ohm resistor, and connect the 330 ohm resistor to the PWM pin 9 of our Arduino. Then connect the cathode pin of our LED to the ground rail of the breadboard. Then hook up the photoresistor onto the breadboard and connect the terminal 1 of your photoresistor to the power rail of the breadboard. And then connect the terminal 2 to the A4 analog pin of your Arduino Uno and connect the connect the 10k ohm resistor to terminal 2 and to the ground rail of our breadboard. With that, let's start coding. Firstly, let's create two variables. In order to do that, we need to use constant. And we're going to name our first variable light pin. Light pin is going to store the value of A4 because our photoresistor is connected to the A4 pin. And then we're going to use const int to do the same for our LED pin. But the value is going to be 9. And we're going to put the semicolons at the end to tell Arduino we're done with this line of code. Now let's set up let's set some things up in void setup. Firstly, let's use the function pin mode. Pin mode tells Arduino that LED pin is an output, and let's end this with a semicolon. Also, we have to use an object called serial, and begin is a function that starts the serial monitor. And 9600 is a value. It's like the speed where we could read off the serial monitor. And we need this to check the brightness of our photoresistor. That's it for void setup. Now let's move on to void loop. Here we're gonna create a variable called light. Well, what light val is gonna do is it's gonna read the uh, readings of our light pin and store it in itself. So analog read light val and give it a semicolon. And now let's print that off onto the serial monitor using the serial object. So serial.println 9600 and then that with a semicolon. Then let's create a new variable called light. Yeah, light. And this variable is gonna use a special function called map. And map is gonna be very useful. So light val 0, 1, 0, 2, 3, 2, 5, 5, and 0. Now I'm gonna tell you what map does. Basically, light valve gets a reading between 0 to 1023. 0 means 0 volts, so it's complete darkness. 1023 means 5 volts, which means it's totally bright. If it's 0, that means the LED is at 5 volts, which means it's as bright as it can get. And 1023 in the outside world means 0 for the LED, which means if it's totally bright, it's gonna be totally off. If it's totally dark, it's gonna be totally bright. And map is used to convert the values from a variable. And all we need to do now is create a function called analog bright. And here we are gonna put LED pin and light. So light is gonna be the voltage that the is how is so light determines how bright LED pin is gonna be. Now that's it with the code. Now let's verify to see if we have any errors. And we do. So it says output was not declared in the scope, so we forgot to place a T. Now let's verify this again. Boom! It worked. So now let's see if our project works. So basically, I placed the code into Tinkercad, as you can see right here. It's just the same code. And now let's start the simulation. And it's totally dark and the LED is totally bright. If it's midday, the LED is kind of bright. And if it's totally bright, the LED is turned off. If it's dark, it's turned on, off, on. With that, see you in the next one. And if you like this video, please like, share, and subscribe.